So I want to tell you why maths is going to hold the future. Right? You heard something that something is going on in the market. Are you reading newspapers? Something is that is stock market, which require maths. Forget about that. There is something which has come in the market, because of that people are losing job. Something taking over. New technology is very good. AI, right? Now, what is artificial intelligence? Basically, you use chat GPT, right?
Yeah.
How chat GPT works?
You send a question and it answers
How it answers?
in codes.
Okay. Code is already done, right?
Yeah.
Here, how they answer. So there is something called matrix method. You have matrix? Okay. So they use matrix method. It's called LLM, large language model. Then there is something called neural network. Everything require maths. Even if you become a doctor, you will need maths first thing. Now the next question is, since many people leave maths and then they face with limited choices. What limited choices I'm talking about? Suppose, I'm not saying that you should not, do preparation of NEET, but I'll just want to give you some statistics of NEET. In India, how many people answer NEET? Close to 25 lakhs, right?
Yeah.
Most of them in India, India has a fascination for taking science after 12th standard, 10th standard, feeling that there is nothing better than science, which is absolutely wrong nonsense. Nothing like that. But let's come to NEET. So people often drop maths of 11th and 12th because they find it very difficult, and then they take up NEET. Good, no problem. But majority of them take NEET just because they could not do maths, first thing. Then the only option left with them is NEET. Then because of that, the competition in NEET is increasing. But the number of seats are not increasing in that proportion. How many seats are there for doctors? 1,18,000. Let's keep it 1.2 lakhs, right? 23.8 lakhs. Let's say 3.8 lakh goes into nursing abroad and everything. 20 lakhs. What happened to these 20 lakhs? These 20 lakhs then go for BSc, then go for MSc, end up becoming teacher. Some go for PhD. So if you want to become a teacher, this is confusion. So have you thought of doing something else apart from NEET? Biotechnology require maths. But it requires maths. Without maths, you cannot learn biotechnology. So if some college is saying that we will teach you AI without maths, it's basically making fool out of people. Similar, biotechnology without maths is too difficult. Maths is going to hold a lot of importance in future. This is what happening, right? You're not saying I'll help you out with, if you want to go abroad also for medical, I'll tell you which countries to apply. That I'll help you with everything. It's not an issue, right? But if you can do maths, if you can develop some interest for math, always better. So one of the reasons why people hate maths is they don't know the practical application of mathematics in real life. For example, differentiation. Right? What is the meaning of differentiation?
Breaking down things into smaller parts.
Very good. Something which is very big, you break it down to smaller parts. Also called finding the slope of tangent, right? Find out the differentiation of something. What you do, suppose there is some curve. Curve has a point, and from that point draw a line, and then finding the slope of this. Now slope of this in 11th standard, you learned slope as 11th standard slope was nothing but equal to either tan theta or y2 minus y1 over x2 minus x1, remember? In 12th standard, that same slope, the tan theta, nothing but it's called dy by dx. change in y over change in x, change in y over change in x. This is change in x, this is called dx, this is change in y, which is called dy. So what is tan theta? Perpendicular upon base, right? This upon this, which is, so that is the entire meaning of derivatives. So you have done derivatives in 10th standard, 11th standard also, now you are doing in 12th standard. 11th standard you wrote it like this, 12th standard you are writing it dy by dx. That's the basic difference, right? Now the question is, what is the practical application of derivatives? Why we are using, where is the one practical application where you have to use derivative? Used many places, in business, in science, in technology. One such example I'll give you. Suppose you are a civil engineer, right? And you have to construct something where you have to pass a pipe. Some pipe is there, which you have to pass from here to here. At the same time, you want this length of this pipe has to be maximized. So if you bring a very big pipe, right? Bring a very big pipe, there is a possibility that it will get stuck somewhere, will not be able to pass through it, right? Or if you take a very small pipe, like this will pass and then lost somewhere, right? So you require some pipe whose length is something which can be easily passed from this without interrupting, without getting interrupted anywhere. At the same time, it will serve the purpose also, right? So in this case, what we do, we say maximize. Remember maxima minima in application of derivative. So this is one of the application. Then suppose I am running a business and my revenue function, right? Revenue function is given as r of x. Revenue function is, let's say, x square plus 0.4x plus 10, something like this. Just random example. My cost function is, let's say, again x square plus 0.3x plus 7, something like this. So revenue is something which you get, cost is something which you have invested. Suppose you are making a pen and you are investing, let's say, 100 rupees and you are selling it at 150 rupees, you are making 50 rupees profit. Now the question is, if I have revenue and cost function, then I ask you find the maximum value of x ka maximum value you have to find out, so that you can maximize your profit. Okay. Right? Profit means revenue minus cost, you have to maximize it. So what should be the value of x? So this is another place where differentiation is used. So there are multiple areas where differentiation is used in real life, and at one point of time everyone wants to do business. There you need it. Most business fail because they are poor in mathematics. People lose money in stock market because people do not have idea of mathematics. So if someone comes and tells you that I'm making a lot of money, ask them, show me your profit and loss statement for 1 year. They'll never show you. Why? Because they're not making money. Unless he is a mathematician, he cannot make a money from the stock market. Right? Okay. So that is basically differentiation. Entire differentiation, I have explained it to you. Now, of course, the first chapter which we have, you need to know the formulas, right? So there is a method to find out, suppose there is a function f of x, right? To find the derivative of f dash x, we use, you don't have to do this, right? It is f of x plus h minus f of x upon h. That is how, this is called derivative by using first principle, which we have already done in 11th standard. Here we don't have to do it because not needed. If they ask you a question based on this, we'll do it. But
Mostly they don't ask.
We need to know the formulas. Suppose you have x raised to power n, so its derivative f dash x will be n x raised to the power n minus 1. Right? So all formulas which we have, first of all, that you should be well versed with. Say if you have f of x is equal to log x. What is f dash x? 1 by x. But if you have 1 by x, So what is f dash x? It is minus 1 by x square. So basically how we reached here using this formula only. So 1 by x, if you want to find out how we got 1 by x, we have to, let's say we have to find out d by dx of 1 by x, which is x raised to power minus 1.
Yeah.
So I am basically using the first formula, n which is minus 1 to x raised to the power n minus 1, which is minus 1 minus 1. So minus 1 x raised to power minus 2. So minus 1 1 by x square. So minus 1 by x square. People write 1 by x also as log x. Right? Then there is an exponential function, right? F of x e raised to power x. Derivative this is e raised to the power x only. If you have root x, so f dash x is equal to 1 by 2 times of root x. 1 by 2 times of root x. Right? 2 times of root x. Right? If you have sin x, so f dash x is how much?
Cos x.
And if you have cos x,
Negative sin x.
f dash x is negative of, you have tan x. Yes. So f dash x is equal to secant square x, right? What if you have cosec x? I am writing this. F of x as cosec x. What is f dash x?
Negative of cos x.
Sin x is cos x is sin, minus sin x is secant square x. Cot x is minus cosec square x, first of all, right?
Yeah.
What is cosec x? So cosec x is minus cosec x into cot x. And if I ask you what is secant x?
Sec x
Sec x
tan x.
tan x. Dash x is secant x into tan x. Of x is cot x. F dash x is minus cosec square x. These are all trigonometric function. Then we have some inverse trigonometric function also, but you have to remember only 2, 3. First is if your f of x is sine inverse of x, what is f dash x equal to? 1 upon under root of 1 minus x square. If you have f of x is equal to cos inverse of x, so f dash x will be equal to minus 1 upon under root of 1 minus x square. And if you have tan inverse of x, dash x is equal to 1 upon 1 plus. So, do we have to remember cosec inverse of x? Yes, you can remember it. But if there is something cosec inverse of x, convert that into sin inverse of x, reciprocal,
Yeah.
and use the formula. Or you can derive it also. Not needed, I mean, if you can remember it, this formula, fine. Otherwise, convert that and you can write it in this form. Right? Clear this much? Okay. Now there is something called chain rule.
Yeah.
We will understand what chain rule is. So if there is any modulus function, can you differentiate it? If there is any modulus function, can you differentiate it?
Yes.
Okay. At all points?
No.
So which point you cannot differentiate it? Suppose you have this, right? So the graph of this will be something like this. Can I ask you, can you differentiate it? Answer is no, I cannot differentiate it at this point. Other points, yes, I can differentiate it. But this is the point where I cannot differentiate it. If so at corners, right? Suppose the graph is something like this. This point, these are called corners. I cannot differentiate this function, right? At the corners. Differentiation at corners is not possible. So if I say f of x is equal to modulus of x, that's why we don't write the derivative of that. Because when I say f of x, that means they're asking you, can you differentiate it at all point? Answer is no, we cannot differentiate it at, right? Right? But this is continuous. So do you have difficulty in continuity and differentiability both?
No, continuity I can manage.
Manage. Okay, great. This is done, right? Noted on this?
Yeah.
Okay. Now let's try to understand chain rule also. You know chain rule?
Yeah.
You find it good or bad?
At first I can do it, but later when the question gets complicated, I forget that you have to apply that rule.
Okay. Now let's try to understand. First of all, what is chain rule? You know the chain, how chains are?
Yeah.
Okay. This is how chains are, right?
Yeah.
If you want to open this chain, can you simultaneously open all the rings?
No.
No. You have to do one by one, right? You have to do one by one. So you take out one, they take out one, then take out one, and then take out one. Now, when I ask the students this question, f of x is equal to x square, and if then I ask them whether we can apply chain rule in this or not. Chain rule means like function के अंदर function.
हाँ.
So is it function के अंदर function?
No.
Okay. Function into function?
No.
Yes. X square can be written as x into x.
Yeah.
So basically you are using UV rule over there, right? X into x. Or else you can use chain rule. Why chain rule? So in this case we have one, this is called algebraic, and this is called exponent. So if I want to differentiate it, so here also I am using chain rule in this. See what we do in this case, you first differentiate means you write 2 in front and the power of x is reduced by 1, right?
Yeah.
After that, you also differentiate the base. Now, first step is differentiating the power. So you differentiated the power. After that, you have to differentiate the base also, which is
One.
x. And derivative of x is 1. That is why answer is 2x.
Okay.
So you are using chain rule everywhere, in this question also.
Okay.
Now, if you have, let's say, f of x is equal to sine qx, right? So this is definitely a chain rule,
Yeah.
right? Sine qx can also be written as sine x the whole cube. First, when you want to differentiate it, so first you bring this 3 in front and the power of sine will be reduced by 1. And then after differentiating the power, you differentiate the base also. Base is what?
Sine.
Very good. Sine x, right? Power differentiation and then base. So now this will become 3 sine square x. Derivative of sine x is cos x. So you are using chain rule here also. We have, let's say, f of x is equal to, right, sine x. Here, see sine x inside the root, so root is also power 1 by 2.
Yeah.
So I differentiate it, right? So I will try to explain you by taking the root thing. It is root x. So derivative of root x is what? 1 by 2. So whenever we have root, that 1 by 2 is fixed. So you write 1 by 2 here also. And then write this entire function back. And then differentiate x, which is 1. Here also you write this whole thing as sin x, and now you differentiate sin x, right, which is equal to what? Under root of sin x, and then this is cos x. Now sometime you have to use that UV rule. Now what is UV rule? D by dx of first u plus minus v is simple, du by dx plus minus dv by dx. Second is d by dx of u into v. So first function into derivative of second function. Here in this case whatever you want you can take first and second in differentiation, not in integration. First function into derivative of second plus second function into derivative of first. And d by dx of u by v. So whenever we have u by v, be very careful while writing this. This is denominator square, first is, then you write denominator only, and then derivative of numerator minus numerator into derivative of denominator, right? But the order, rest everything is fine. So we have some question where we have to use chain rule, simultaneously we have to use UV rule together, right? Right? You have to use chain rule. For example, you have f of x, see instead of f of x, even if they write y, don't get confused, y is same as हाँ सर लिंक भेज देना, हाँ लिंक भेज दीजिए. Right? You have something like this. So now first we have to apply UV rule here in f dash x. So take one function as u and one function as v. Want to try this? Do it. Hello. So here any function has first function. So first function which is sin x cube into derivative of this. See, this is not cos x whole raised to power 5. This is cos x raised to the power 5.
Yeah.
So first you write this as sin x raised to the power 5. And then since it is chain rule, right, this and this function, then you differentiate x raised to the power 5 as well. Keep this function, only keep on differentiation by using chain rule and everything. Plus second function, which is cos x raised to the power 5, and then derivative of sin x cube, right? So when you do sin x cube, cos x cube, and then you have to do for x cube also. Like how here we did directly.
Yeah.
Otherwise I would have written sin d by dx of sin. So now this is sin x cube into sin x raised to the power 5, and this is 5x raised to the power
So
4.
will it be negative sin x?
Sorry, negative, correct. So you bring negative sign plus cos x raised to the power 5. Sin x cube is cos, and then x cube is
3x.
3x square. And then simplify. So already differentiated everything. Right? If you have, now this is the final answer. Simplify it. Now if you have, let's say cos x raised to the power 5 inside the root, something. So first you always differentiate, because whole power, right?
Yeah.
First you differentiate the root part. So derivative of root means 1 by 2 times of whatever is inside the root, you write it as cos x raised to the power 5. Then you differentiate this whole thing, which is minus sin x raised to the power 5, and then you differentiate x raised to power answer, right? This part of derivative is clear. Now certain substitution, because now some exercise in some places you have to use substitution also. So those substitution you should remember. And these substitution is basically derived from 10th standard only. In 10th standard, we have learned 3 identities. First is sin square theta plus theta is equal to 1. 1 plus secant square theta, and 1 plus cot square theta is equal to cosec square theta. Remember this, right? Here I can also write this sin square theta as 1 minus cos square theta. Here, if it is in this form, fine. So I'll just write this as 1 plus tan square theta is equal to secant square theta only. See, I can use this in various ways. I can write secant square theta minus 1 is equal to tan square theta. I can write that tan square theta. I can write this as secant square theta minus 1. And same way 1 plus cot square theta cosec square theta, can write it in this form. So, sometimes you do get question where whether roots are involved or not. It's a different thing. If you have 1 minus x square, you have x square minus 1, x square plus 1. So when you have 1 minus x square, in this case, put x is equal to either sin theta or cos theta. Whenever we have 1 minus x square. Here in this case, put x is equal to secant theta or cosec theta. And in this case, put x is equal to tan theta or cot theta. So if you see, you can actually draw some conclusion. See, 1 plus tan square theta, 1 plus tan square. So these conclusion can be drawn. So whether roots are involved or not, you can use this. But if roots are involved, definitely you should use this. Right? right? Take this off.
Yeah.
Oh. Okay. Now in differentiation, implicit function. So what is implicit function? What is explicit? Right. Explicit means x and y has no, I mean, there is no direct relation between, direct relation, like if I say y is equal to sin x, right? So here x, the value of y depend on the value of x, what we take x, right? So here both are not dependent on each other, but y is dependent on x. In explicit, one variable is an independent variable and second is dependent on that. So if I take x is equal to 30 degrees, so y is equal to sin 30. If I take x is equal to 45, 60, any angle if I take, right? If I differentiate this, so dy by dx is equal to cos x, right? So in this is called explicit function. In implicit function, both are dependent on each other. For example, if I have y square is equal to xy plus sin x. This is just an example of implicit function. If I have this function, right? If I or say simply y is equal to, and if I ask you to differentiate this function, so here see x and y are dependent on each other. Over there x is an independent variable. But when you multiply x and y or x square y, xy cube, anything, then they become dependent on each other. So when you differentiate this with respect to x, so this is dy by dx. Here you differentiate this function. Forget about sin x for some time being. Differentiate this function. So first function into derivative of second function. When I am doing xy, right? So if I take this as u, so this has to be taken as v. So first function into derivative of d by dx of y, which is dy by dx. So first function derivative of second function plus second function into derivative of x, which is 1. So your answer is dy by dx is equal to x times of dy by dx plus y. You can bring all dy by dx on one side and then you take dy by dx as common. So it is 1 minus x is equal to y. So therefore dy by dx is y upon 1 minus x. Right? So that is called an implicit function. So all implicit function has to be solved. Just make sure that should not do mistake. For example, if I have to differentiate x square, if I have to differentiate y square with respect to x, so x square is 2x, y square is 2y, and then dy by dx. Right? That is implicit function. Here?
Yeah.
Let's do some question.